Okay, question number 1. We have f of x is equal 4x to 6 plus 3x cubed. We need to determine whether this function is a polynomial function or not. If it is, we need to identify the degree. First of all, which the function we call polynomial functions. The function that has degree whole number, that we call polynomial. If we would have degree, let's say fraction, or if we would have degree negative, or decimal notation, anything else but whole number, then it's not a polynomial function. Okay, since we have whole numbers 6 and 3, then we have polynomial. Okay, so what is the degree? So we are looking if the variable is the same, x and x. Obviously one can be x, one could be y. So in this case variables is the same. We take the highest variable, highest degree 6, and that will be the degree of polynomial. Degree is 6. Next question, number 2. F of x, we have 2x to power 7 minus pi x to 4 and plus 1 over 6 x cubed. So one thing I have to tell you from the beginning, the fact that we have coefficient ladder pi, that we know it's 3.14, or we have fraction as a coefficient, not as a degree, it has nothing to do with polynomial, no polynomial. What we need to pay attention again is the degree. 7, 4, 3. Are they whole number positive? Yes, that means it is polynomial. So we have polynomial. Do we have all variables the same, x, x, x? Yes. That means we pick the highest degree, which is going to be 7. So the degree of polynomial is 7. Question number 3. We have h of x is equal 4x to 5 plus 5x cubed plus 2 over x. Okay, we have what do we have? 2 to power 2 over x, which means I can rewrite it 4x to 5 plus 5x cubed plus 2 times x to power negative 1. Why? Because 2 over x is equal, represent as a twice, meaning 2 over 1 times 1 over x. And 1 over x is nothing else but x to power negative 1, based on property of exponent, where x to power negative n is equal 1 over x to power positive n. And accordingly, if I have 1 over, let's say, a to power negative m, this is going to be a to power positive m. So over 1, which means negative degree, it's always flipping the fraction. See here we have degree 1, a denominator 1. Let me put blue color because denominator is not given. We are just representing as 1, so picture would be clear, right? And since we have negative, it's flip the fraction. See, we get 1 over x to power n, just n is positive. If I have 1 over a to power negative m, so once you flip the fraction, you get a to power positive m, and 1 goes to bottom. Now, 1 over x, it's good, that same thing I can write down. X to power negative 1. Why? Because if I have x to power negative 1, let me represent as over 1, and result is going to be 1 over x to power positive 1, right? Which is the same thing. Okay? All right. So, moving on, since we have negative 1 degree, that means it's not a polynomial. Okay? All right. Question number 4. I have, let me clean this, so maybe I can rewrite on this side. Okay, I am moving to write on this side here. Question number 4. So we have g of x is equal x to power 1/3 minus 3x plus 5. Okay, do we have here 1/3, which is fraction, therefore not a polynomial? Remember, polynomial, algebraically polynomial, we identify the function that doesn't have fractions, doesn't have negative exponent. Not a polynomials. Why I say algebraically? Because there is a way to identify polynomial by graphing also. Okay. There we go. Now we will identify by graphing. Is the graph of polynomial is a polynomial function? Okay, let me build the graph. This is question number 5. And I have here another one. I'll make it small. I don't need to take this much space. Okay, and if my graph looks like this, then this is polynomial. Why is that? Polynomial cannot have cut. Let's say comes here and then goes like here. Okay, polynomial cannot have sharp angle like this. It has to be smooth, okay, without interruption, because that is why the domain of polynomial, it's always going to be negative infinity to positive infinity. Okay? All right. Next. So this is polynomial, obviously. This graph is polynomial function. Number 6. Well, let's take a guess on this one. I'm curious. So one goes this way, another one goes this way. Is this a polynomial? Correct. You are absolutely correct. This is not a polynomial because it has break, okay, in the area of 0. And it doesn't touch y-axis, doesn't touch x-axis. So it has a break here, right? There is a break, therefore it's not a polynomial. Number 7. So, and this is identification by graph. So if I have number 7, let me make this one smaller so it's taking too much space. Much better. And this one also. Okay, so can move this up so I can place 7. Number 7, graph. Okay, and I have graph like this. Yes, this is polynomial. It's smooth. Polynomial function doesn't have break and it goes smooth, right? Okay. So next, question number 8. So we have the function f of x is equal x cubed minus 2x squared minus x plus 2. Okay, so this is polynomial, obviously, because all degrees are positive, and we don't have fractional degree, and we don't have negative degree. So therefore, it's a polynomial function. Now, we are going to build the graph. We are going to learn how to graph polynomial function. So step 1, or A, we always start building the graph from end behavior. Any polynomial, you always start from the end behavior. Let me explain how it works. So the general form of polynomial is a n x to power n plus a n minus 1 n minus 1 x to power n minus 1 and so on. What we are interested in the highest degree of the polynomial, which in this case is 3. Let's write down. We need this for n behavior, we need a nth coefficient of the highest degree term and n. So our a nth is, in this case, is 1, right? Let's see, here it is, it's 1 and highest degree 3. So x cubed, it's the term with highest degree, and n here is 3, obviously. So here is 1, this is a, and here is highest degree 3. So how we gonna identify end behavior and which way it goes? Here is the template. So first of all, we are looking 2 cases. A is greater than 0 and a is less than 0. Maybe I would just move this on the side, so we will keep it as a template. Put right here. And it will be based on this example. Now, if a is greater than 0, so then we are looking n is odd, and we are looking n is even. All right, so the graph for a greater than 0, when n is odd, then the end behavior on the left side is falling down, and the end behavior on the right side is rising. So what kind of graph in there? We don't know. We just built end behavior. Let me make it blue color so we can separate. Oops. Okay. Now, if n is equal even degree, then we are going to have the following picture. Even, then we are going to have both endings and behavior goes up. Like this. Now, what is inside? We have no idea, and it's not important. We are exploring with end behavior. That's the first thing we start with, step number 1, to graph polynomial. All right, now we move to a is less than 0. Okay, a is less than 0. Let's see how it's gonna look, the shape. Now we will have less than 0 again, n is odd, and we will have n is even. So when n is odd, then the left end behavior goes up, right end behavior goes down. What is in the middle, obviously, nobody knows for the template. And the other one, when both are even, take a guess. That's right, it's gonna go down both ends. It's gonna go down. So let me make it easy for you to remember and understand. This one also. So let's take first even degree. When degree is even, both endings are going one direction, which means either up or down. If a is positive, coefficient a is greater than 0, then both ends going up. If the a is less than 0, which means negative, then end behavior, both ends are going down. That's that easy. Next, let's find similarity. Degree is odd for a greater than 0 and a less than 0. So look here, if you can pay attention and see, it's when you look at end behavior for n is odd, let's say for a greater than 0, can you see that it reminds you linear equation that it's increasing? Yes, and here it reminds you when a is less than 0 and degree is odd, it reminds you linear equation or linear graph that goes down, decreasing. So that's how approximately you can remember. All right, so n is odd. For if it's positive, then it's increasing, growing. If n is odd, a is negative, then the graph is going down. Okay. So this is end behavior. Now let's apply for our case. I'm cleaning here because we made it template, right? And we keep right here on the side. Now let's apply. So for our case, a is equal 1, which is greater than 0, right? Okay. And n is equal 3. How the graph is gonna look like in our case? Let me put it together. Okay, so A is positive, A is 1, which is positive, we're coming this way, and N is 3, which is odd, we're coming this way. So the graph, it's gonna look like this. And behavior, left side fall down, upper side, right side going up. Okay, this is one element. Next, B. So we need to find X-intercept. That's step number 2, to find X-intercept. X-intercept and then Y-intercept. Okay, so let's find X-intercept. Remember when we are building the graph linear equation or quadratic equation, we are building graph. We find X-intercept and Y-intercept based on Y is equal 0 or X is equal 0. For X-intercept, we have to take Y equals 0. Therefore, for Y is equal 0, this our function, right? I'm writing down and putting equal 0 because Y is the same thing as f of x. Let me make it more clear. F of x, that is same Y and it's equal 0. So we take Y0 to find X-intercept. To find Y-intercept, we take X is equal 0, okay? So let's find X-intercept. We have x cubed minus 2x squared minus x plus 2 equals 0. Okay, we have 4 terms. To simplify, work out 4 terms, we usually apply trying. First thing we are trying, it's a method of grouping. Okay, if it would be 3 terms, then I would try to see if I can factor it down. But we are now using grouping method. So it's going to be x cubed minus 2x squared. And here, since I have minus, then within parentheses, I'm going to flip every single sign. Negative x will become positive. Positive 2 will become negative y. So if I open parentheses, go back, so I will get the same thing. Let's say x cubed minus 2x squared. So if I open parentheses, positive x will become negative x. Negative 2 will become positive 2. See, I got the original one. Therefore, okay, let me clean it. Okay. Now, once we at the group, let's take common factor. From the first parenthesis, common factor is going to be x squared. Inside will be left x minus 2 minus x minus 2 equals 0. Here is interesting factor. We have common factor for both terms. This is one term. This is another term. Terms are identified based on addition and subtraction between them, not multiplication. See, multiplication here included as in the term. So if I take x minus 2 from both sides, from first term I will have left x squared. From the second term I will have left only minus 1. That's all. Equals 0. Okay, x squared minus 1. Let me remind you that's a formula, difference of squared, where a squared minus b squared is equal a minus b and a plus b. Now here we have x squared minus 1 squared, which is the same 1. So from here I can break it down. X minus 1, x plus 1 equals 0. And here we have x minus 2. All right. So we have three parentheses multiplying by each other equals 0. When product is 0, that means either of these parentheses has to be 0, right? So to get a result of multiplication 0. So from here we have either x minus 2 is equal 0, where x is equal 2. We have x minus 1 is equal 0 when x is equal 1. And we have x plus 1 is equal 0 when x is equal negative 1. So our x-intercept, it's going to be negative 1, 1, and 2. This is our intercept. Okay, it's not working. I need to take. Never mind, I'll just underline it easier. All right. Now, what else? We need to mark down our this intercept. All right. Right now, I'm analyzing by pieces, by elements, and then at the end, we will put all pieces together, okay? So we have negative 1, we have positive 1, and we have positive 2. Okay, we have positive 2. So, what for do we need this intercept? We found out at which point it's gonna cross our graph. Let me bring in our end behavior. So one is going down here, the other one is going up. Our goal, once we found out x-intercept, to find out whether the graph is gonna just in this point cross this way or this way, I don't know, or it's gonna just turn around this way or this way. Okay, how we gonna identify? So I'm starting with the intercepts that are the closest to the end behavior, which are this negative 1 and which is positive 2. Let's see how I'm going to identify based on multiplicity. Multiplicity is the degree of each parenthesis. Let me write out again here. I have here x minus 2, x minus 1, x plus 1 when I broke down completely before I found the answer. What is the degree of this parenthesis here? Degree is 1. Here is also degree is 1. Here is also degree is 1. Now, those are we call multiplicity. We call multiplicity. What does that tell us, multiplicity? If multiplicity is, let me add here, I'm going to add to this template. If multiplicity is odd, which in our case all three are odd, then the graph is gonna, this is our intercept, x-intercept. So then the graph, it's gonna cross from left to right or from right to left. We don't know yet. But if multiplicity is even, then once this x-intercept, the graph is going to curve, turn around this way or this way. Now, if it's odd, we would have example here, let's say x minus 3 to power 3 or to power 5. Yes? or to power 1, which I won't have any power in there, right? Okay. And if it's even, it can be, let's say, x plus 2, degree 2, or it can be degree 4, or it can be degree 6, as long as it's even. Okay? Now, in our case, we have x minus 2, it's degree 1. Let me write down x minus 2 multiplicity is equal 1. X minus 1 multiplicity is equal 1. And x plus 1, degree 1 multiplicity is 1, which means all three we have odd. So let's figure out which way it's going to cross, from left to right or from right to left. So we start, like I said, from the closest to the end behavior, which means first we start -1 and then +2, closest to the end behavior. So we know that it's going to cross. If I draw like this, it's going to be disconnect with the end behavior, right? So obviously it's going to cross this way. So I can connect it to my end behavior. Yes? Okay. And accordingly, the point 2, it's going to cross like this, right? It's going to cross like that, so I can connect to end behavior. Otherwise, if I draw like this, there will be disconnect with end behavior. This is why we start with end behavior first, because it will help us to identify how it's going to cross X intercept. Okay, and then I'm connecting to end behavior. All right. Now, this point at point 1, which is this one, x minus 1, here it is, equal +1. So what do we have? Look here. This end is on the top. This end is at the bottom. Yes? That means this intercept, it's going to cross like this, so it can connect. Yes? Okay. Now, how it's going to connect? It can go down, let's say, like this. Or it can come straight like this. The same thing here. Let's say it can go up like this. Or just goes slow like this. How do we know which way it's going? If we are interested, so we have to take some point at, let's say here, 1.5. Plug in our original problem, right here, the original problem, and calculate, see how much my y will be. Okay? I just don't want to do right now because 1.5 is not a good number. But you can take calculator and do it. But what will help me in this case? What will help me in this case? Since it's gonna cross my y here, then I can figure out my y-intercept, right? And I will know approximately how high it will go. Okay, so let's find it. Now this one, I just already know that graph is gonna come close like this. But for you, if I wouldn't know, then I would have to take value in the middle somewhere here, which will, if this is 1, this is 2, so I will take 1.5, and again I would plug to original equation, and calculate my y. Let's say 1.5 cubed minus 2 times 1.5 squared minus 1.5 and plus 2, and see how much I would get. And I assure I should get negative number. Okay. But to save time, I already know it's going to go like this. But I can find Y-intercept to see where it's crossing Y. To find Y-intercept, I'm going to get, see, Y-intercept, I have to take x is equal 0. So if it's x is equal 0, what do I have? So for x cubed minus 2x squared, our original problem, minus x plus 2. Okay, how much it's gonna be? It's equal our y, right? So if I plug 0, this is gonna be 0, this is gonna be 0, this is gonna be 0 plus 2. So my x-intercept is equal to, so by coordinate 0 and 2. So let's see. See, I have it very low, so, oops. This will be my 1, and this will be my 2. Okay, which means my graph, it's gonna go from here and go down. So let me clean it. Okay, well, I'm going to do this. Okay, and this one also, if I clean from here, gee. Okay, this is better. And I lighten, okay. All right, so this is what we have. Let me make this end behavior nicer. So, okay, this is how it's gonna look, our polynomial graph. What else we have there? Yeah, we already built and we are done. Okay, let's go next one. We are going to build another one, obviously. Question number 9. Question number 9, what do we have here? F of x is equal x to 4 minus 16x squared. All right. So let's see. And behavior. So our A is equal 1, right? Here it is. Highest degree is 4. So coefficient is going to be our A. And our N is equal 4. So we have coefficient A here is positive, and N is equal even 4, which means both ends are going to go up. So those are going to be my end behavior of this graph. Next, find x-intercept. This is question A. Sub-question, rather saying. Find x-intercept. To find x-intercept, we have to take y is equal 0, which is our f of x, which is y, which is 0. So we have x to 4 minus 16x squared, and that is equal 0. Okay, so if I take x squared out, right, common factor, I will get x squared minus 16 equals 0. X squared minus 16, again, we are applying this formula, a squared minus b squared, right here. A minus b, a plus b. So which means it's going to be x minus 4 and x plus 4, because 16 is 4 squared, right? And here we have x squared. And that is equal 0. So we have our x-intercept, which is either x equals squared equals 0, where x is equal 0, obviously, or x minus 4 equals 0, which x is equal 4, and where x plus 4 equals 0, where x is equal negative 4. Let's identify multiplicity. For this first case, multiplicity is equal 2, which means it's going to curve, right? Turn around. In this case, multiplicity, let me put in parentheses, is equal 1, yes? And in this case also, multiplicity is equal 1. Okay, well, let's build. Yeah, I don't think it's straight. Let me fix it. Okay, now we have it straight. All right. So what are our endpoints? I mean, x-intercept. 1, 2, 3, 4. 1, 2, 3, 4. Positive 4, negative 4. So this is 1 point. This is another point, and third point is 0. So my end behavior, we know it goes like this, right? This is my end behavior. Now let's see. I'm starting to figure out based on multiplicity. First, taking care of points negative 4 and positive 4. See how it's going to connect with end behavior. Now, at the point of negative 4, here it is, negative 4. My multiplicity is 1, which is going to cross, right? And it's going to cross like this. Let me get another one, thicker. Okay, and here it's going to cross. Okay. Now, the same way, it's here, it's coming down here. And it's going to cross also this way, right? Because end behavior goes that way. Okay. Now, at the point of x is equal 0, we have multiplicity 2. Now, both ends are at the bottom. What does that mean? It's going to curve up or it's going to curve down. Obviously, it's going to curve down. Yes? So you can connect because both my ends are down. All right. Now, how much it's going to go down? Nobody knows. So for that, let's see, we can take the whole number and calculate and figure out how far down it will go. Yes? Okay, let's see. I'm going to take, if this is negative 4, this is positive 4, this is 0. Well, 1, 2, the truth is, let's take 3, okay. 0.3, negative 3. And we plug in there. So let's see if my x is equal 3, negative 3. We try and find out how far it's gonna fall. Okay, so x is equal 3. I'm getting negative 3 to power 4 minus 16 negative 3 squared. This is our original one, right? That's where I'm plugging. Let's see what we get. Negative 3 to power 4, it's going to be positive 81. And negative 3 squared is going to be 9. And 16 times 9 is going to be minus 9 times 6, 54. 9 times 1 is 9. And 5, it's going to be 14. Minus 144, which is equal. 144 minus 81, we need to subtract. It's going to be 3 and 63. That's going to be great. Negative 63. This is what I would do here. Look. I'm going to make it. This is how I will do. Okay. Here I will have cut like it's continuing. Okay. And put here 63. So when x is equal negative 3, y is equal negative 63, which means this graph is going to go like this. And accordingly, if I take positive 3, it's going to get same number because my degrees are even here, yes? So it's not going to change the sign. I'm going to get same negative 63. So here is 1, 2, 3. So it's going to come down to precisely this way, I would think. I would say it would be right to build this a little bit. Let me see. Because we didn't take the center between negative 4 and 4, it would be 2, but I took negative 3, but that's okay. I'll go like this. It has to turn like this. And this one also. And get connected. So it's going to be identical at the bottom, and this is going to be our graph. We need to find out also Y-intercept. For Y-intercept, we take x is 0, although on the graph, since it's turning point, on the graph, we already can say that if x is equal 0, y is going to be 0 also. But let's do it. Since it's asking, we will do it. Okay, x is equal 0. Then we have x to 4 minus 16x squared equal how much? It's going to be 0 minus 0 is equal 0. So x-intercept, y-intercept. All right, we got it. Now, determine the symmetry of the graph. Well, obviously on the graph we can see that it is symmetric to y-axis, which is even, right? It's even. So the graph that is symmetric to y-axis, we say that f of negative x. If I plug positive x, if I plug negative x, it's going to be the same, like we did. Negative 3, positive 3. And which means it's even. If they are equal, it's even. and symmetric to y-axis. That's all. Question number 10. Another one, f of x. Let's make more space. F of x is equal x to 4 minus 8x cubed plus 16x squared. Okay, we have to build this graph. All right, let's see what's gonna happen. So end behavior, our n is 4, highest degree, and our a is 1. Well, let's for the, okay, well, it's 1, which means the graph end behavior is gonna go, so a is positive, n is even. So end behavior is going like this. Okay, B. We need to find x-intercept. X-intercept. So we are taking y is equal 0, which is f of x is equal 0. And from here we have x to 4 minus 8x cubed plus 16x squared is equal 0. All right. So what we can do, this is, there is no grouping obviously because we have free terms here. But what is interesting, I see every single term has x squared, right? Which means x squared I can take out. I will have x squared minus 8x plus 16. And I got beautiful quadratic trinomial, quadratic equation. Perfect square, I would say. Okay, so from here, x squared equals 0, which means x is equal 0. And for the second, x squared minus 8x plus 16 equals 0, which means there are two ways. One way you can factor it down, which you will get x minus 4 times x minus 4 equals 0. Or the other way, I would say more professional way, or better way maybe, to use apply perfect square formula, which is a plus or minus here also, minus b, I'm going to combine both, plus or minus is equal a squared plus 2ab, formula perfect square, plus b squared. And for the case of minus, here is minus. Now the thing is, we are given this form and we need to get this one. Let's check. I'm checking by this, my a and b. If a squared is x squared, then I will have a will be x, right? X to power 2. Okay, now next checking b squared. So it's 16, right? So which means here I can put 16 as a 4 to power squared, which means my b is 4. Yes? Now let's check here. Since I have negative 8x, which means in my case it's going to be negative twice a. My a is x and my b is 4. Did I get this original problem? Yes, I did. X squared minus 8x plus 16. Now you can say, well, this way is easiest, obviously, but to make it easy your life, what is how you can go faster for this? Perfect square, meaning you take square of first number, you take square of second number, and then multiply by each other and double it times 2. Let's see. Square of first one, which is going to be x to power 2. Square of second one, which is going to be 4 to power 2. Let me write down 4 to power 2 and x to power 2. And then multiply by each other. 4 times x, it's going to be 4x. Let me write right here. Move down so I will have space. Yeah. Minus multiply by each other 4x, and double it times 2. So I get 8x and I'm done. So it's your choice. Either way, it works. So, which means x minus 4. Let me clean this from here. So we take the mess away. And we come back to previous position where we have practically x squared equals 0 and x is equal 0, and we have x minus 4 squared equals 0, right? Because excuse me, this is equal x minus 4 squared, correct? X minus 4, x minus 4. From here, x minus 4 also equals 0, and x is equal positive 4. Maybe I'll move here. And the whole thing I'll bring here a little bit. And all right. And x is equal 4. So let's look at the multiplicity. We have two X intercepts. Okay, where multiplicity for this case is equal to, which means it's gonna curve around, turn around, and the other one also multiplicity is also equal to, which is going to turn around. All right. So let's build the graph. See how it will look like on the graph. So x is equal 0. This is one point. The other point is 4. 1, 2, 3, 4. This is the other point. We have 2 points. Our end behavior goes up. We remember that, right? It goes up. Okay. Now, multiplicity for x is equal 0. Multiplicity is 2, which means it's going to curve around or turn around. And because my end behavior is up, that means it's going to turn up. Now, multiplicity is 2. This is 0, is 2. It's for x is equal 4. It's also going to turn up because it's even and going to turn, and because end behavior is up, so it's going to turn up. Now let me do nice connection to both X intercept. Okay. One more time. This is this way. All right, not bad. Now the question is, right in the middle, how it's gonna connect to each other. This way, right? We find out. Obviously, we can say that there is no other y-intercept but 0. It's right here. Yes, we can take care of it. So we have C. So for y is equal 0, to find out how much will be y-intercept, I'm taking x is equal 0. And I have x to power 4 minus 8x cubed plus 16 x squared. Okay, and how much it's gonna be? Let's say if I take x everywhere 0, 0 minus 0 plus 0, so we get y is equal 0, so we get 0, 0. And y-intercept is equal 0. So which we saw on the graph already. We just confirmed algebraically. And the last step we have to find out here at which point, how high the graph is gonna go here. So I'm taking the point, wait a minute. I'm sorry, this is 4, sorry for confusion. I'll take middle point 2 and see how far we will go with this. With 2 we can calculate. So we get 2 squared. I'm writing in this original equation, or in this case expression. So 2 to power 4 minus 8 times 2 to power 3 plus 16 times 2 to power 2. Okay, 2 to power 4 is 16 minus 2 to power 3 is 8. 8 times 8 is 64. And then plus 2 to power 2 is 4. 4 times 16 is 64. So 64, negative 64, it's gone. So the answer is going to be 16. So for x is equal to, this is equal 16. So how far is 16 is? Well, we will do the same way. I'll put here dashes, which means we are doing cut. And 16, let's assume this is my 16. So which means it's gonna turn here and connect here. And that's we get our graph. All right. Okie dokie. Moving to next question. Question number 11. Question number 11. F of x is equal negative 2x to power 4 minus 4x to power 3. All right. Let's see. A. And behavior. So my A is equal negative 2, which means A is less than 0, and my N is equal 4. This is 4, and this is negative 2. Okay, which is even. So the graph is going to go like that, end behavior down. Yes? So we have here a is less than 0, n is even. Both of them are going down. Next, we are going to find x-intercept. Let's find. So for x-intercept, f of x is equal y is equal 0, and we get negative 2x to 4 minus 4x cubed is equal 0. Taking out negative 2x cubed, I'm getting x minus 2 plus 2 is equal 0, because if I take negative, so it's going to flip sign in the parentheses, right? It was negative 2x to 4, negative 4x cubed. So in parentheses will become positive y because I took negative sign out. All right? So, and what do we get? Negative 2x cubed equals 0. From here, x is equal 0. Or x plus 2 is equal 0, which means x is equal negative 2. All right. So what do we have in this case? We have multiplicity is equal 3, which is odd, and multiplicity here is going to be 1, right? We have two multiplicities that's going to cross the x-intercept. All right, so let's see, let's draw the graph. Okay, so x is equal, we have endpoints down, we already know. So x is 0 and x is negative 2. Let's say this is my negative 2. Okay, so since my endpoint is going to be down, which means it's going to cross like this. Yes. Now, since the other end behavior also going down, so from from x is equal 0, it's also going to go down. And it's going to go like this. Okay. Well, and this one we can calculate where it's going to be, since negative 2. This is negative 2, this is 0. We can take 1, negative 1. So if I plug negative 1, x is equal negative 1. So what do we get? Negative 2 times negative 1 to power 4 minus 4 times negative 1 to power 3. It's going to be negative 2 times 1 minus 4 times negative 1, which means negative 2 plus 4, it's going to be positive 2. So which means positive 2, it's going to be 1 somewhere here, positive 2. 1, let me see. 1, 2, 3, okay, so it's going to be here too. So it's going to come like that. It's going to come like this. Okay, make some splash and go down. All right, and this is going to look our graph. And we can check also Y-intercept, which is clear. Y-intercept is going to be 0 because it's crossing only at the point where x is equal 0. But we check algebraically also. So x is equal 0, and we have our original one is this. So what we are going to get, negative 2x to 4 minus 4x cubed. So it's going to be 0 minus 0. Result is 0, which we have right here. Okay. Now, if we talk about symmetry, we can say that graph is not neither symmetric about y-axis nor symmetric about origin. So there is no symmetry in the graph. Question number 12. So we have 4x cubed minus 4x minus x to 5. F of x. See, my highest degree is right here, positive 5. Let me write down, and n is at the 5. How much is my a? Negative 1, right? So this is 5, and this is 5, and this one is negative 1. Here we have negative 1. Okay, let's show end behavior. It's negative, and n is odd, which means it's going to go like this. Okay, end behavior. Okay, let's go to X Intercept. What do we have? For x, for X Intercept, we take y is equal 0, which is f of x also equals 0. Okay, let me put it here so nobody wonder. Because y is a function of x. That's why, right? So 4x cubed minus 4x and negative x to 5 plus negative x to 5 I put in front. It's the highest degree. So it equals 0. What can I do? I can take, let me see, negative x out. I don't want highest degree, stays negative. All right. So it is going to be negative x I'm taking out. I will have x to 4 minus 4x squared and then plus 4. See, I flipped every single time the sign in parentheses because I took negative sign out. Therefore, x to 5, negative x to 5 became positive x to 5, x to 4, and then let me see, positive x to 3 became negative x squared, and negative 4x became plus 4. Because I took negative sign, it flipped every single sign in parentheses, okay? Let me take off not to make it mess. All right. So from here, what we are going to do, so negative x is equal 0, right? Because it's multiplication. And second one is x to 4 minus 4x squared plus 4. This is going to be, again, perfect square. Or you can break down x squared minus 2, x squared minus 2. either way, or perfect square also would work, which would be x squared minus 2 squared. So if I open it on the side, let me do drafting here, x squared minus 2 squared, it's equal x squared squared, and then b squared, it's going to be plus b squared, which is 2 squared, and in the middle, what did I say? You take square of a, square of b, right? Square of a, square of b, and in the middle you put multiplication of a and b, which will be 2x squared, and double it. Did we get our result? Yes. All right. So it's going to be x squared minus 2 squared, which means if I have here x squared minus 2 squared equals 0, that means x squared minus 2 is also equals 0, x squared equal 2, and x will be equal plus minus square root of 2. So in this case we get, let me here change the color so you will know where is our x-intercept. It's right this one, and the other one is this. Okay, so multiplicity here is equal 1, right? Because you have here 1, correct? And for this case, we get multiplicity is equal to. Why? Because here we have these 2. So it's going to turn the point, around the point. All right? So how the graph it's going to look like here? Let's see. Building this point. And then building the other point. So first one is going to be x is equal 0. Then I have negative square root of 2, it's 1.44. Let's assume this is negative square root 2. And this is positive square root of 2. Where is my end point? Okay, so this one is going to go this way, this one is going to go this way. So what do we have? We are exploring negative square root of 2 and positive square root of 2. Since we have multiplicity is 2, that's meaning in both cases they are going to curve, right? So obviously negative square root of 2 is going to curve this way, and positive square root 2 is going to curve this way, since they both are going to curve. Therefore, what's going to happen? Let me curve this or turn around, and the graph from here is going to go like this. And graph from here it's going to go like this. So what's going to happen in about 0? At the 0.0 we have multiplicity 1, which is going to cross, right? So, and obviously since this one we have on the above x-axis, this one have below, and it's clear which way it's gonna, which way it's gonna cross. So this is gonna cross this way, right? And the graph, it's gonna go like this. It's not gonna splash high or too much down, because what do we have? Our original graph is this one. So if I take about -1, what's gonna be? -1 of this one, it's gonna be, let me see, -4. And then a -1 is gonna be +4, it's gone. And -1, -1 to power 5 is gonna be -1. With -1, it's gonna be +1. So this is gone, it's gonna be +1, it's right here somewhere. Okay, and same way it's going to be with negative part, with +1. It's going to be -1. Okay, we are good. And this is how your graph, let me make it look better here. And this is going to be our graph. Question number 13. Since polynomial, it's a difficult subject for students, I made sure we did enough. So let's figure it out, what we have here. All cases, I try to include every single case we can possibly have. F of x is equal -4, x minus 4 squared, x squared minus 4. All right, so how we are going to find here the highest degree of polynomial and leading coefficient of a. So leading coefficient of a is -4, because this is our leading coefficient. Why? Because this first x is going to be the highest degree. If, x squared, raise x to power 2 here, and then multiply by x to power 2, it's going to be x to 4. So this first coefficient in front of parentheses is going to be leading coefficient a. Now, n degree, this is more interesting. We need to calculate. So, 2 parentheses. Here I have degree 2. Here I have degree 1. But inside I have 1. Degree 1. Inside here I have degree 2. So, for the first parenthesis, it's going to be 1 times 2. And then plus, here I will have 2 times 1. So this is this 1. This is this 2. Here this is this 2. And this is the 1. So 2 plus 2 coefficient, and the degree is going to be 4. All right? That's how we calculate. So how will the graph and behavior will look like? What is going to be our end behavior? A is equal -4, which is negative, and n is an even degree. So end behavior goes like this. Now let's do X Intercept, which means f of x is equal y is equal 0. So from here, -4 times x minus 4 squared and x squared minus 4 is equal 0. So to simplify, -4 times x minus 4 squared, here x squared minus 4, it's a difference of squared. Remember, that's a squared minus b squared, which is equal a minus b, a plus b, which means this one, it's going to be here x minus 2 times x plus 2 is equal 0. Okay, so from here we have three parentheses, which means first case x minus 4 squared equals 0. So from here x minus 4 is equal 0 and x is equal positive 4. So this is going to be our first intercept. Next one, x minus 2 equals 0 and x plus 2 equals 0. So here x is equal 2, x is equal negative 2. Multiplicity for this one is 2. Multiplicity for this one is equal 1, right? And multiplicity for this one is equal 1. How? Here it is. Okay, now let's start building graph. Forgot to take shape. This is 1. This is other one. So those are our excuse me, our intercepts. So what do we have? 1, 2, 3, 4. I want it to be this color so we can see. All right, 1, 2, 3, 4. This is 4. And then we have positive 2. And here we have 1, 2. This is negative 2. All right. So our end behavior goes down. So first let's take care of the ones that goes close to our end behavior. So negative 2, since my end behavior, multiplicity is 1, it's gonna go cross the point, right? Since my end behavior is down, so it's gonna go like this, cross like that. And if I connect to end behavior, it's gonna be like this. Next, 4. Again, my end behavior is down, so it's gonna cross like this. Okay. Now let's figure out what's going to happen to intercept 2. This is 2, this is negative 2, this is 4. Oh, wait a minute, positive 4, it's curving. Okay, multiplicity is 2. Here it is, I'm sorry. So, which means it's going to be it's gonna curve or turn around like this. There we go. For some reason I was looking at the x is equal to. Okay, now for 2, it's gonna be clear, it's gonna cross, and multiplicity also, we have 1, and one end is above. X-axis, the other end is below, so it's gonna cross it, right? It's gonna cross it like this, because if other way it would cross other way, we would lose the connection, we wouldn't be able to connect. So the only thing we need to know, since obviously it's gonna cross y-axis somehow, So we need to find out at what point it's gonna cross y, which means I'm going to take x is equal 0 and find out y-intercept. So y-intercept, it's gonna be equal, where is it? Oh, here it is, -4 times 0 minus 4 squared, and then 0 squared minus 4, right? I used this original one, or this one, doesn't matter. I think that the first one I used. Yeah, doesn't matter which one. Okay, and the result is we get -4 times what we get, -4 squared, it's going to be 16 times -4. So it's going to be positive 16 squared, I think is 256. Wow. I think it's 256, 16 squared. So I'm going to break here and show the break. Or they do also this way. Okay. So that also works. So I put dashes. Okay, and 256, let's say it's gonna be somewhere here, 256. Now the question is, it's gonna come and curve here, or it can go at a higher and then come cross here. So to find out the answer on that question, we are going to take, let's say, position -1. Let's see how much will be at the point of x is equal -1. So we are absolutely clear that y-intercept, it's going to be 256. It's going to cross this point one way or another. But let's find out in the middle of that the interval between 0 and -2. I'm taking x is equal -1. X is equal -1. So what do I get? So -4 times -1 minus 4 squared, and then -1 squared minus 4. So what do we get here? -4 times -5 squared, and then times 1 minus -1 squared is 1. 1 minus 4 is -3. So result is this will be -5 squared, 25. 25 times -4, -100. And then times -3, it's going to be 300. So see, it was the right thing to do to check it, which means it is going to go up. Let me see. 300 is above 256. This is what I will do. Well, that's okay. So let's make this is the 300. Let's assume this is 300. So -1, 300 point, and coordinate. So this is gonna come here. And come down here, connect to this one. Connect to this one, and from here, if I take this is 3, so this one is going to be a small curve. You can count it, but I already look at the equation. I can't say it's going to be some small curve. There is not going to be splash, because number is big enough. It's 3 and we have there 4, so it's going to get close to negative 2 or close to negative 2, something like that. And here it is. This is our graph. Okay? Moving to question number 14. So we have f of x is equal x squared times x minus 5 cubed and x plus 2. Let's see what's the degree here. What's the degree of polynomial and what's the coefficient here? So, degree of polynomial, x squared, so we have 1, 2, 3 terms we multiply by each other. Well, this all is one term, but it consists of two parentheses and one x squared separate. So we need to find out the highest degree. So let's find out. X squared, it has degree 2, plus x minus 5 cubed, x degree 1 times 3, it's going to be 3, degree 3. And for the second parenthesis, x plus 2 is degree 1, because 1 and 1 times 1 is 1. So we get degree 6. So what do we have? And yes, coefficient, leading coefficient is 1, which is positive. So let's start. Leading coefficient A is equal 1 and degree n is equal 6. So what does that mean? A is positive, n is even. So n behavior goes like that. Okay. Next we are going to get intercepts, X intercepts. So for B, we need to take f of x is equal y is equal 0. Therefore, x intercept, it's going to be equal x squared times x minus 5 cubed times x plus 2 is equal 0. As you can see, we already have broken into parentheses, which means we don't need to do any kind of simplification. All we have to do, take x squared equals 0, either x minus 5 cubed either equals 0 or x plus 2 equal 0. So x squared equals 0. From here, x is equal 0. X minus 5 to power 3 is equal 0, which means x minus 5 is also equal 0, because if you take cubic radical from both of them, it's still going to be 0. And from here, x is equal positive 5, and x plus 2 equals 0. X is equal negative 2. So let me color the intercept equal 5, 0, and negative 2. Okay. Now let's figure out multiplicity. For x squared, multiplicity is 2, which means it's gonna turn at the point of 0, right? For x minus 5 cubed, multiplicity is 3, which means it's gonna cross through point. And the third one, multiplicity, it's equal 1. Okay, is equal 0. So now let's try to place it on the graph. So 0. Next is gonna be 5. 1, 2, 3, 4, 5. And next is gonna be -2. So this is -2. And this is +5. All right. So end behavior is going both to the up. Let's see, multiplicity for x squared. No, we need to learn to -2 and 5 because those are closest one to end behavior. For -2, multiplicity is 1, which is gonna cross, right? It's gonna cross, and since my end behavior is on the top, it's gonna come like this. There we go. Next one equal 5. Multiplicity is 3, which is gonna cross. And since end behavior on the top, so it's gonna cross the 5. It's gonna cross the 5. Same as this one. Okay, now both of them are the points are below of x-axis, which means it's gonna come, and since x squared multiplicity 2, it's a turning point, so it's gonna come like this. Now our point at our task find out how deep it's gonna fall before it's connect. So we can, oops, what happened? Yeah, our task is to find how deep it's gonna fall, or it's gonna be just shallow. We'll figure it out. So at here at this end, I'm taking -1 to find out where it's gonna be at point -1. So let's write down at x is equal -1. So I will have -1 squared, -1 minus 5 cubed. That's the equation, right? And then I will have -1 plus 2. So this is going to be 1. This is going to be -6 cubed. It's going to be negative. 6 squared is 36 times 6. It's going to be 216. Well, looks like we're going to build some cut here because 216. And it's going to be times +1. So it's -216. Great. Let's do this then. And then I'll make a cut here. So assuming this is 216, or I could go by different, well, that's okay. I'll put here 216, okay, at the point -1. So let me see. -1 is here. So it's gonna turn around like this. and come here. Okay, and this is coming here. It cannot cross y-axis because it has turning point at 0, right? That's why I'm not worried to check if it crosses y-axis or not, because I know that here at x is equals 0, it has turning point. So at this point I'm safe. I'm turning around here. And now I need to identify how far it's gonna drop this one, 0, 5. Let me take, okay, 2. I'll take 2. So if I take at this between 0 and 5, I'm taking 2 to see how far it will go. So 2 squared, 2 minus 5 cubed, 2 plus 2 equals 0. So what do we get? 2 squared, 4 times 2 minus 5 is negative 3. Negative 3 cubed is going to be negative 27. And then 2 plus 2 is 4 equals 0. 4 times 4 is 16. And let me see, 16 times 27, it's going to be 432. Negative, I don't know why I put negative. Negative 432. So it's going to go deeper than this, right? And this is 2. Since middle is 2.5, so my turning around point, it's going to be here at 2.5. I just picked 2, so it would be easy to calculate. Let me see. Like this. Okay. And this is gonna be your graph. Okay. So to check regarding y-intercept, it makes no sense because we know it's going to be 0, because that's the only point. It doesn't cross y anywhere. And indeed, since if you look here, we have x, x, x everywhere. So if we plug, let me see, x is equal 0, so it's enough to place this one 0. So the rest it will wipe down to 0, correct? All right. Therefore, we know y-intercept equals 0 only at the point of 0. And lastly, if we want to know if it's we have it any symmetric here, it's not symmetric to origin or not in symmetric to y. There is no symmetry here. Question number 15. I have 2 more questions and I will be done. You have plenty of questions to make sure you learn this topic very well. Number 15. F of x is equal negative x squared, x minus 1, and x plus 3. Okay, so let's start. How much is my highest degree? Let's go over. Here I have 2, here I have 1, here I have 1. If I add, it's getting 4. Okay, n is equal 4. A is equal negative 1. Yes, here it is, this negative. There is no other coefficient. That means negative 1. Okay, so end behavior is going to be this. Next, Y-intercept. So Y-intercept is going to be, X-intercept, I'm sorry. F of x is equal y is equal 0, and X-intercept is equal negative x squared times x minus 1 times x plus 3 is equal 0. From here, negative x squared equals 0, which is x is equal 0. X minus 1 equals 0, which is x is equal 1. And x plus 3 is equal 0, where x is equal negative 3. Let's moving to multiplicity. Multiplicity for this one is 2, which means turning point. For this one is 1, right? For this one also 1. All right, so let's draw the graph. Okay, what do we have? End behavior is down, so we have 0, X-intercept, positive 1, and negative 1, 1, 2, and negative 3. So negative 3, it's going to be crossing. Okay, positive 1, it's also going to be crossing because multiplicity 1 and end behavior is down. Now 0, at the point of 0, it's gonna curve. X is equal 0, it's gonna curve because both endings are open ends are in the positive y area. That means this at the point of 0, this point, it's gonna go like this, right? So it can connect. So all we need to know how far it will go. We're gonna splash or it's gonna connect. Now this one, if I take 0 and 1, so let me see. If you plug the calculator, it's gonna go something like that. Place, let's say 0.5 here. Take x is 0.5. It's gonna go very low. And for this one, between negative 3 and 0, if you take 1 or 2 and plug it here, negative 1 or negative 2, you are going to get about, let me see, about 11 or something like that, something similar. So I am just going to show, oops, that it's gonna go like this. This is 2.5, oops, 2.5, and like that. So to know precisely how it will go, you just take any value and you will find it. I approximately know it's gonna have some splash there. All right, we got that also. And for the Y-intercept, it's very easy because we have everywhere, question number 15 here it is, we have everywhere x, so this here, if I plug here 0, that's it, it will wipe down the whole multiplication to 0. Therefore, our y-intercept equals 0 at the point where x is equal 0. And lastly, regarding symmetry, there is no any symmetrical information here on the graph. Okay, and the very last one, f of x is equal negative 2x cubed. I have x minus 2 cubed. Let's take square. X plus 5. All right, so let's see, a, how much is my n, how much is my a? A is negative 2. The n, we need to count it. This is, we have 3, here plus 2, here plus 1, 6. Which means we are going to have n behavior going down. Both of them are down because a is negative. Yes? So this is how it's gonna look like. Negative, and it's even, so going down. Okay, next we need to find out our x-intercept. We are going to find out our x-intercept. All right. If y is equal 0, then we have negative 2x cubed times x minus 2 squared, x plus 5 is equal 0. Okay, so from here, x cubed, negative 2x cubed is equal 0, which means x is equal 0. Then we have x minus 2 squared is equal 0, which means x minus 2 also 0, x is equal positive 2. And here I have x plus 5 is equal 0, x is equal negative 5. Now here I can just put x minus 2 squared, which is going to be x minus 2 is equal 0. I don't know why I put this parenthesis, I can take it off. And from here, only x is equal 2. Okay, x is equal 2. Now let's put multiplicity. In this case, multiplicity is going to be equal 3. Here, multiplicity is going to be equal 2. Let me, here is 3, here is 2, and here is going to be equal 1. We have three multiplicities, meaning the three X intercepts, and multiplicities. We have two odd ones and one even one. Let's see. So end behavior is going down, both of them. Let's start with further one, negative 5. 1, 2, 3, 4, 5, negative 5. Positive 2. And 0. Okay, since at the point of negative 5, we have multiplicity 1 and behavior going down, so it's going to cross. Okay, at the point of, let me see, 2, we have multiplicity 2, which is gonna curve, and it's gonna turn down because my end behavior is down, right? Okay, now let's understand. At the point of 0, multiplicity is free, right? Which means it's going to go intercept through 0, intercept 0, it's going to cross. Now, if you want to see how far it will go, you can take point of x somewhere equal at negative 5, 4, negative 3, for example, and here take, if this is your 2, take 1. But I already know how it's gonna look like looking at the problem, so it's gonna be something like that. Okay, it's gonna be big splash. So if I put here, if this is 1000, I'm going to break down like that. So this is gonna be around 400 something, 400 plus something. Okay, and this small one, it's gonna go very, very close. Hold on. It's gonna go like that. If you get plug 1, you will get, since this much is 400, so you're gonna get very close to your origin. And it's gonna go like this. Okay, you want to do it, calculate it? Okay, let's take it and calculate it. X is equal 1. Let me do this one so you won't have question hanging over your head. So negative 2 x cubed, x minus 2 squared, x plus 5. Let's do it. We are taking x is equal 1. We are taking this point, right? 1. So x is equal 1, I'm getting negative 2 times 1, because 1 cube, okay. 1 minus 2 squared, and 1 plus 5. So it's going to be negative 2 times, negative 2 squared is going to be 4 times 5. This is 20 times 2, negative 40. If this much is my 400, negative 40, will it be here? Yes. Okay, and that is gonna be your answer. And what can we say about symmetry? This graph, it doesn't have any symmetry about y-axis or x-axis nor for origin. And that's it. I am done. I'm not hiding. I have enough. So I'll see you next topic. Thank you for watching.